last class, we discussed about the school of working of synchronous motor. And the next one is the why synchronous motor is not a self-starting motor. So here, different methods are there to start the synchronous motor. Here we have taken the help of certain devices to start the synchronous motors. So that methods here, those devices are used to start the synchronous motor. So each are having the different methods. So that's why today we are going to study about the methods of starting synchronous motor. Okay. So as seen earlier, synchronous motor is not a self-starting motor. Synchronous motor is not a self-starting motor. So it is necessary to rotate the rotor at a speed nearer to the synchronous speed. Nearer to the synchronous speed. Why? Because here synchronous motor is not a self-starting motor. So here to rotate the synchronous motor, here it is necessary to rotate the rotor of the synchronous motor by the external device. So here different methods are there with the devices. Here four methods are there. The first one is the using pony motor. Using pony motor. And second method is the using damper winding. And third method is the as a slippery induction motor. And fourth one is the using small DC machine coupled feed. The total how many methods of starting of synchronous motor? Four methods of starting synchronous motor. Using pony motor, using damper winding, with the help of slippery induction motor, with the help of small DC machine. The help of small DC machine. So let us first we have to study about the using pony motor. Using pony motor. See that here? The first one is the using pony motor. What is the meaning of pony? Pony is nothing but small. In this method, the rotor is brought to the synchronous speed. The rotor of the synchronous motor is brought to the synchronous speed with the help of some external device. That device is the small induction motor. Small induction motor. So such external device is called as pony motor. Such external device is called as the pony motor. So once the rotor attains the synchronous speed, so then the DC excitation to the rotor is switched on. Then the DC excitation rotor is switched on. So you see that here, when we given the excitation to the rotor winding of synchronous motor, when the rotor attains the synchronous speed or nearer to synchronous speed, then we are going to switch on the excitation. So when the excitation is switched on to the field winding of the rotor, so here the speed of the rotor and the speed of the stator both are equal and both are magnetically locked. So that is we call as synchronism. The speed of the rotating magnetic field is equal to the speed of the rotor. That one we call as the synchronism. So synchronism is established by pony motor. And when the rotor attains the synchronous speed, then we are decoupled. The pony motor. So there is no use of pony motor when the rotor attains the synchronous speed. So after the rotor attains the synchronism or synchronous speed, we are decoupled. That is the removing the pony motor. See that here, this figure. So this is the figure. So this is the figure related to the pony motor. So this one is the small induction motor. It is coupled to the rotor. The rotor of the induction motor is coupled to the rotor of the synchronous motor. So first we are given the supply to the pony motor and we are rotating. See that here just he taken as a type of pony motor is the DC motor. Now we discuss about the induction motor. Instead of DC supply, we are given the AC supply. So this is the method of using pony motor to start the synchronous motor. And next coming to point of next method is the using damper winding. Next method is using damper winding. See that here. Next method using damper winding. This is the figure. So this is the figure related to using damper. See that initially, first The rotor of the synchronous motor consisting of the here first is that first the rotor of the synchronous motor is which type of rotor? Salient pole type of rotor. Here to run the rotor automatically, here in the pole faces of the salient pole, north pole and south pole. In the pole faces of the salient pole, so we are arranging the some bars, rotor bars, copper bars. So copper bars are placed in the rotor pole faces of the north pole and south pole. North pole and south pole like that. Here the pole faces are placed in the south pole and next one is the north pole. And those bars are short circuited by end rings. Those bars are short circuited by end rings. See that? Those bars are short circuited by the end rings. Those bars are short circuited by the end rings. So now it acts as a squirrel gauge rotor. It acts as a squirrel gauge rotor. It acts as a squirrel gauge rotor. When the supply is given to the stator of three-phase synchronous motor, the rotating magnetic field links to the rotor of the synchronous motor. Rotor of the synchronous motor. That is, so when the rotating magnetic field links to the rotor of the rotating magnetic field, that is, it cuts. So these conductors are conservatic lines of force and EMF will be induced. So now the entire rotor acts as a squirrel gauge rotor of the induction motor. Squirrel gauge rotor of the induction motor. So now these rotor rotates with a certain speed, subsynchronous speed, that is the less than the synchronous speed, that is nearer to the synchronous speed, When the rotor rotates nearer to the synchronous speed, now we switch on the DC excitation. So when the DC excitation is switched on, here there is a synchronism exists between the rotor and the stator magnetic field. And one more important point. So when the synchronization is exist or achieved between the stator and rotor magnetic fields, here there is no use of the copper. There is no use of these copper bars or damper winding. So why? Because here the relative speed of the rotating magnetic field and the relative speed of the copper parts are both are same. So in that case, there is no cutting of flux by the rotor conductors to the stator magnetic field. So then the IMF induced in the rotor damper winding is equal to zero. Is it all of understand? So here in this method, the second method using damper winding, so the rotor runs as a squirrel gauge rotor. The rotor runs as a squirrel gauge rotor. So that's why this is the method we can use to start the three-phase synchronous motor. And next one is the third method is that as a slippering. So as a slippering induction motor. Is that here as a slippering induction motor. What is the next method here? As a slippering induction motor. So the above method discussed, that is the starting of synchronous motor as a which type of induction motor? Spiral gauge induction. Type of induction motor? Spiral gauge induction motor. So you know that here two types of induction motors are the spiral gauge induction motor and slippering induction. So the squirrel cage induction motor can be used for the moderate torque. Where we require the moderate torque, there we use the squirrel cage induction motor. But it is not preferred for high starting torque motor. So here to develop here it is necessary to develop the high amount of starting torque in a synchronous motor. So that can be achieved. So here what is the drawback we faced in the using squirrel gauge using damper winding that can be overcome with the slip ring induction motor. See that here the same damper winding. So instead of short circuited, so we bring out the damper winding from rotor to the external, and they can be connected in the slipper. They can be connected to the slipper. See that here, so this is the winding can be connected to the slip rings through the external resistance. Through the external resistance. See that here the torque depends on the starting torque depends on the rotor resistance. Depends on the rotor resistance. Here also same. First, we are given the supply to the which winding stator. We are given the supply to the which winding stator winding. So when the supply is given to the stator winding, the rotating magnetic field is produced in the stator. Rotating magnetic field is produced in the stator. This rotating magnetic field is cutted by the damper winding, which is placed in the pole faces, north pole and south pole of the salient phase. And next important point, see that the winding is connected to the which one here slip rings. It is connected to the slip ring. So when the speed of the rotor is nearer to subsynchronous speed, then we are giving the DC supply. We are giving the DC supply. The DC supply is given to the excitation. So here also the magnetic field produced in the rotor. So here there is a magnetic locking between the stator and rotor. Strong magnetic field between the stator magnetic field and rotor magnetic field. Strong attraction. So then that is we call as synchronism. That one we call as a synchronism. See that here, what is the drawback we are placed in the second method that can be overcome with the third method, slip ring? Why here the damper winding can be connected in the slip ring connection to provide the high starting torque. Provide the high starting torque. That is the only difference. The last method and next one is the third method. Last method and okay, that is okay. Next. The fourth method is using small DC machine. Using small DC machine. So this kind of method of starting of synchronous motor we use it in the laboratory. Our DC machines laboratory. Here, see that the large synchronous motor, the synchronous motor is coupled with the DC machine. So that machine acts as a DC motor. First, we are giving the supply to the DC motor. Okay. So it rotates the rotor of the synchronous motor, and along with that, we are giving the excitation. We are giving the so here giving the excitation. Then the excitation to the rotor is provided. Once the motor starts running as a synchronous motor, the same DC machine acts as a DC generator. DC generator called as exciter. The field of the synchronous motor is then excited by this exciter itself. Here, four methods of starting we studied. The first one is the using pony motor, and second one is the using damper winding, and third one is the as a slip ring induction motor, and fourth one is the using small DC machine. Using small DC machine. These are the four methods to start the synchronous motor. Very, very important. Synchronous motor is not a self-starting motor. Synchronous motor is not a self-starting